Hello, so this is just a short video on how to find the LCD and bring together several rational terms. The kind of instructions for finding an LCD would look like this. First of all, you're going to factor all your denominators, and then you want to just list all the different factors, and finally multiply together the highest power of each factor. Now, in this particular example, the denominators are pretty much already factored, so we can kind of ignore the first part of this. But let's take a look at some of the other ones. If you look at these terms in the denominator, there's really two factors. There's an A and a B. So that's all there is to step two. And I like putting that as a second step because, it gives you a little more organization and helps you out with the third step. Because in the third step, you're going to look at these factors, look at the A, look at the B, and say, well, what's the highest power of either of these in each of these denominators? So the highest power of A is a 3 here, and the highest power of B is a 4 here. So that's going to be our LCD. It's A to the third times B to the fourth. Now, there's a temptation a lot of times to want to add up the exponents, like 3 plus 1 will give you an A to the fourth, and 2 plus 4 would give you a B to the sixth. That's not the case. You just want to find the highest power of each factor anywhere in your denominators, and that's it. So with our LCD right here, let's see if I can make that a little bit, all right. So with our LCD here, we want to take and multiply each of these fractions by something so that each denominator has the LCD. So what you do is you look at what's missing. For instance, I've got an A cubed here. Well, I need the B to the fourth term. From the middle term, I'm missing 2 A's and 2 B's. And from the last term, I'm missing an A cubed as part of the denominator. So let's introduce those terms so that when we multiply everything together, each of these denominators is going to be A to the third times B to the fourth. Now, when you multiply, you're really going to multiply by 1 in the form of something over itself. So you can see I did that in each of these. I've got B to the fourth over B to the fourth, for instance, or A to the second times B to the second over A to the second times B to the second, and so on. Now, when you multiply these things together, you'll have the common denominator, and you can bring everything together over that common denominator. So put everything in the numerator over that common denominator. Be careful, you can't then cancel, say, the B to the fourth with this B to the fourth or something like that. This whole term in the numerator is one term. You can't kind of cancel into that. So this is done. Yay. Let's try another one that has some binomial factors in it. So it might be a little bit more of a challenge in particular. That gives us a chance to try and factor things first. So let's take a look at this one. Directly out of your web-assigned homework. Here's your denominators. The first two are already factored, but the third one isn't. So the first step, as I outlined above, was to factor all these things. And that just means factoring this as the difference of squares. So hopefully pretty easy there for you. The second step is just to list the different factors. Well, that would be your x plus 1 and x minus 1. Those are your different factors, and that's it. That's all we have to worry about there. Now, over here, we're going to multiply together the highest power of each factor. Now, there's an x plus 1 here, but there's an x plus 1 squared here, which is where I get the squared term for this part right there, is that that's the highest power. The highest power of x minus 1, well, there's only one x minus 1, and that's implied it's to the first power. So that's what we'll multiply together. And here in total is our LCD. To finish this one up, we're going to have to introduce some terms in each of these denominators so that each of these denominators has the LCD. So let's see what that's going to look like. From this first one in blue, I can see that I'm missing an x plus 1 term and an x minus 1 term. So that's what I'll multiply by in both the numerator and denominator. So this term in red is my attempt at getting a common denominator. Likewise, from the middle term, I'm missing the x minus 1 term. And from the last term, I need an x plus 1 term. So I multiply by that in both the numerator and denominator. Here, when I multiply x plus 1 times x minus 1, I know I'm going to get the difference of squares. So I didn't actually do all that multiplication. I just put the answer x squared minus 1 down here. In the next step, I'll distribute the 3. Likewise here, I just distributed the 4. That leaves this negative out in front. And if you notice, I put parentheses around the x minus 4 term because I'm eventually going to have to distribute that negative to both of these terms. That means I'll get a negative 4x and a plus 4 when I do that. Finally, 9x plus 9, we're okay there. Let's move down. I distributed the 3 to this numerator term here. All these terms have the LCD, so I can bring them together over one common denominator. Now, I'm just being lazy here. I'm writing LCD as opposed to writing x plus 1 squared times x minus 1. It's just easier. It also helps you avoid the temptation of canceling some of these terms in the denominator. Some people do that. They'd be going around in circles because you got the LCD, and then if you cancel it before you add the numerators or subtract them, whatever, then you're going to be back where you started. In any case, so I distribute the 3, and I took a little extra time here to show you that you have to distribute that negative to both of these terms. So I kept the parentheses around that numerator here and showed you in this next step that, yeah, right here, that's where you have to distribute. So I get a negative 4x plus 4. Final step is to combine like terms. As a last step, make sure you put in the actual common denominator. Don't write LCD here. Your instructor won't like it, and more importantly, neither will WebAssign. So good luck with those.